Scientific notation on a calculator. On many scientific calculators, you can enter numbers in scientific notation by using a function labeled EE or EE, small and then caps. Usually, the letter E takes the place of times 10. So the number 4.1 times 10 to the ninth would appear as 4.1 E9 on the calculator.
When numbers get really, really big, sometimes writing them using scientific notation is a really, really convenient way to actually write numbers and study them in a manageable way. Let's take a look at an example where the numbers are going to get really, really big as we look deep into the ocean. Let's check it out. So this table shows the approximate areas for 3 oceans given in square meters. Now here's our challenge. To figure out what is the total area of these 3 oceans, and then let's see if we can write the answer in scientific notation using more appropriate units. There'll be a little bit of unit issue here going on here. So here we see the area for the Atlantic, the Indian, and the Arctic Ocean in meters squared. And so, for example, the Atlantic is 7.68 times 10 to the 13th. So the exponent is 13. And what that means, of course, is that basically from right where the decimal point is, if you want to write this number out, you've got to move this over 13 spots to the right. So it's going to be a really, really long number. Check it out. I'm going to write it up there. Look at it all. Really, really long. Okay. So this is a compact way of writing it. So if we want to find out the total area for these, of course, all we have to do is just add up those 3 numbers. So all we have to do is just add them up. Boom, boom, boom. So that's not so bad. And if you were to add them up, we notice that since in each case we have, and then I'm writing this, of course, in scientific notation. So scientific notation is just a shorthand way of writing this, where I write the 7.68, and the E means the exponent on the power, on the base 10 is 13. So this is the same as that, and that's a shorthand way of writing that. A lot of calculators will actually give answers in this way. You can try this on your own calculator as well. So 6.86 times 10 to the 13th in scientific notation is just 6.86 E13, which means 6.86 times 10 to the 13th. The E stands for the exponent on 10, and then you multiply. And then similarly here for the 1.41, E13 means 1.41 times 10 to the 13th. Well, these are all units that are basically 10 to the 13th, 10 to the 13th, 10 to the 13th. So if you want to add them all up, all you have to actually do is add up these numbers here, the ones in front, and then the units will be E13. So in fact, if you add them all up, you'll get 15.95 E13. But we can rewrite that like this, because this is the same thing, but now I have E to the 14, because instead of a 15, I pushed this decimal back here, so this number now is going to be less than 10. But that involves me multiplying the answer by another factor of 10, which means instead of having 10 to the 13th, I now have 10 to the 14th. So this actually means the same thing as this. And so you can see these ideas coming together. So if the number out in front to the left of the decimal point gets really, really big, we can just actually move the decimal to the left and then just eat up more factors in the power of 10. And that's what we did right here, for example. Okay, so there's the answer, and that answer is, in fact, in meters squared. So I should write meters squared. But that's such a huge, huge number, and we're challenged now to wonder if we can use more appropriate units. Well, I think we might want to be thinking about kilometers instead of meters, because kilometers are bigger, and so we can get a whole bunch of meters can be written just as 1 kilometer. In fact, 1,000 meters, as you know, is equal to 1 kilometer. So since 1 kilometer equals 1,000 meters, what we can do is, if we want to know what 1 kilometer squared is, then all we have to do is square 1,000. And to square 1,000, it means we're multiplying 1,000 by itself. which means how many zeros are we going to have? We're going to have 1 with 6 zeros, which means 10 to the 6th. And so what we see here is that in terms of area, we see that 1 kilometer squared equals 1,000 squared meters squared, and that is 10 to the 6th meters squared. And so this is a great way for us to take this huge number and merely make it large. And the way we're going to do that is now convert from meters to kilometers. And what's the rule? The rule is that 1 kilometer squared is equal to 10 to the 6th meters squared. And so 1 kilometer squared over 10 to the 6th meters squared is going to be the conversion factor that's going to get us from one to the other. So here's what we're looking at. Let's check this out and see this is really what we got. So this is nothing more than the answer we found in meters squared. I multiply by this conversion ratio, because we see that 1 kilometer squared is the same thing as 10 to the 6th meters squared. And so what happens? Well, first of all, check out what happens to the units. There's a little bit of simplification. The meters squared downstairs, the meters squared upstairs, they go away. So they simplify, and I'm just left with kilometers squared, which is exactly what we want. And then what are we left with? Well, we're left with this thing times 1, which is that thing, divided by 10 to the 6th. So there you have it. So all we have to do is figure this out. But here we can actually do a little bit of use of exponential rules. Because if I have a factor of 10 to a power on the top and 10 to a power on the bottom, then all I do is look at the exponents and subtract 14 minus 6. So this, in fact, equals the 1.595 times 10. But now check it out. You see how it's 14 minus 6, because it's a 10 to the 14th divided by 10 to the 6th. And we subtract the exponents here, and the units are still kilometers squared. And now, what is 14 minus 6? Well, of course, that's 8, and so I can now see that I can write my answer in more appropriate units, in kilometers squared, by writing it as 1.59 times 10 to the 8th kilometers squared. And that is, this value here is a smaller value than this. And that's because the extra zeros, if you will, are eaten up by the fact that I went from meters squared to kilometers squared. I made that conversion. That conversion allows everything to happen. So, the answer, I'd say, is 1.595 times 10 to the 8th kilometers squared. That represents the total sum of the area of these two oceans. So using scientific notation and being careful with exponents is a really valuable way of writing numbers that are really, 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 really long, that can be written in a very compact manner for us to analyze, think, and actually manipulate. In this case, we added them. Have fun thinking about exponential and also scientific notation, and I'll see you soon.